There are times when you may want to display information from multiple query paths in the same result set. One way of achieving this is by using result set operators. Maybe you want to see a result set that displays people and their person aliases. You may also want a list of people and their encounter aliases. Using a standard join path in this example, you only get people that have both. Also, if a person has more than one person alias or encounter alias, there will be duplication in the result set. Using the union result set operator, you can see a unique list of person aliases and encounter aliases in the same result set without there needing to be a match on both. Discern Explorer supports the union, union all, intersect, and minus RDBMS result set operators, allowing the output of two or more queries to be combined into a single result set. The result set operators place data into separate rows using shared columns in the result set. Compare that to a standard join, which uses separate columns to display different data on the same row. Union returns the distinct rows returned by any of the queries. It allows you to combine the results of multiple queries while it removes any duplicate results. Union all returns all rows returned by any of the queries, including duplicates. Intersect only returns rows that are returned in all the queries. This would be similar to how a standard join path would operate. Thus, a match between the queries would be kept in the main result set, and those that did not match would not be returned. Minus returns distinct rows from the first query that are not in the following query. This sounds similar to what exception logic used in a join path would yield. The union operator is probably the more common of these operators. The Oracle union provides the ability to select different paths of data with similar data sets within one parent query. A union merges the result sets of multiple select statements. There are several limitations and requirements that must be followed when using the result set operators. We will discuss those shortly. First, let's look at an example of where the union operator may be useful. Here's an example showing why we may want to use the union result set operator. One result set gets person and encounter alias information, while the other result set gets person and person alias information. Here we can see data coming from the encounter alias side, that is the visit ID and FIN number for Bill. Now we can see data coming from the person alias side, that is the SSN and CMRN for Bill. Using two select commands with the union operator allows us to combine those two different result sets into one result set. Thus, we can see the data in the same column. We could have used one query to capture this information, but we would have ended up with duplicate data because Bill has multiple encounter aliases and multiple person aliases. Also, that data would be separated out into different columns. Let's dig into those requirements that we need to be aware of when using the result set operators. First, the queries must return data sets that contain the same number of fields with the same data types in the same order. The RDB union control option should be used to help ensure that the queries return data sets with the necessary information. Normally, If a Discern Explorer select statement uses report writer clauses, then only the fields that are used in the report writer sections are passed in the select list of the query that is sent to the RDBMS. This prevents fetching data that is not used from the RDBMS. However, if the RDB Union Control option is used, Discern Explorer will pass all the fields from the select list in the query that is passed to the RDBMS. All items in the select list of each query should be assigned to an expression. The same expression names should be used in all the selects to ensure consistency. These names can be used in the report writer sections to capture the data contained in that field. Expression names used in the select that is embedded in the result set operator must conform to RDBMS naming expectations. For example, the expression name cannot begin with a number. The queries embedded in the result set operator have some limitations specific to them. You can only use fields or literals in the selection list. No functions can be used to create expressions. That would include UARs like UAR get code display, as well as functions like substring. Qualifications can only use functions that are directly supported by the RDBMS or can be converted to a bind variable. Remember that there are certain Discern Explorer functions that have a direct RDBMS level equivalent. Those are acceptable to use. However, not all Discern Explorer functions or combinations of parameters for functions have a direct RDBMS equivalent. Those cannot be used. Since our bind variables act like a placeholder for literal values passed down to the RDBMS, then anything that can be converted to a bind variable would be acceptable as well. The reason that a bind variable is preferred over just passing down a literal value is that they allow the query to look the same from one execution to the next. That allows us to use a cached execution plan. These queries can only use RDBMS tables. Lastly, we can only link tables using a single where clause. No plan and join syntax can be used here. These restrictions are in place because Discern Explorer passes the queries contained in the result set operator directly to the RDBMS level without doing any cleanup or conversions. Thus, we can only include those things that would be known at the RDBMS level or that can be converted to a bind variable. After the last result set operator, the select can use the order by clause to sort the entire result set by the expression number. So if you want to sort by the third item in the select list, then you'd use the number 3 in the order by clause. You can use the report writer clauses to format or process the data in the result set. You should use the with clause containing the RDB Union Control option, as that will ensure that we pass down all the fields in our various select lists to ensure we satisfy the requirement that the number of items and data types in our select list are the same. You can use multiple result set operators, but you'll only have one with clause. Let's look at an example of a union query. We have combined our two queries from the previous screen. This one is capturing the person alias information. Notice that we have our select expressions built out. It can be helpful to put a literal value in there to designate which query that the data came from. That is what we're doing with the side expression. This select can use the plan and join syntax because it is not contained in a result set operator. This select is capturing the encounter alias information. It is contained within the union result set operator, so we must use a single where clause. We do have our select list built out with the same expression names and the same data types as our other query. Notice that the side now is being populated with EA to indicate that this data is coming from the encounter alias query. Remember that we'll sort by the expression number rather than the name. First, by the first expression, or the name, and then by the fourth expression, or side. We do have the RDB union control option in the with clause. This will ensure that all expressions are sent down to the RDBMS level, thus ensuring the appropriate number of fields and data types are present. Here is the combined result set. The data is sorted by the first column of name in ascending order. We can see the alias and type, as well as the side that this data came from. The first two rows for Bill are from the encounter alias side, with the next two rows for Bill from the person alias side. The first two rows for Sue are from the encounter alias side, with the last row for Sue from the person alias side. It would be helpful to have the display value of the various alias type code fields. However, that is one of the limitations of the result set operators. We cannot use the UAR get code display in the result set operator select. However, we can use our report writer sections, which would be able to use the UAR get code display. That data cleaned up using the report writer sections could look something like this. We see each name just one time, as well as each side descriptor just one time per person. We can also see the display values of the alias types. Looks good. For this class project, the hospital, in conjunction with the local mental health wellness center, is doing trend analysis research on mental health and hospital visits. They are attempting to understand the best approach in helping people get the most accessible help needed for mental health emergency. As part of that study, they want to see how many of their patients with an emergency medicine service also have a relationship to a social worker. The query should get encounters registered in the past year that either had a specific medical service of emergency medicine or where an encounter has a relationship to a social worker. Our parent query will capture encounters registered in the past year with a medical service of emergency medicine. We will then use the union result set operator wrapped around our second query to select encounters that have a relationship to a social worker in the same date range. We will then display the results from both queries, displaying the encounter ID, registration date, the table from which the row was retrieved, that is the query side of emergency medicine or social worker, and the appropriate code value, either the med service code or the relationship code. Okay, let's jump into DVDev and see what this would look like. All right, we have a new prompt program here. We'll start with the parent select. We can use Query Builder to help us out. This query will capture information related to emergency medicine. What table would we find that information on? If you're thinking encounter, then you are correct. We will grab the encounter table. It would likely be helpful to know something related to the patient, like their name. How about we grab the person table as well? Now, let's select some fields from the Fields tab. With the encounter table selected, we can move over some fields, like encounter ID, reg date time, and the med service code. From the person table, we can move over the name full formatted field. That should hold us over for now on the fields. Let's build out our qualifications. Since this query is not going to be contained inside of the result set operator, we can use the plan and join syntax. We do not have to, but it is an option. What table should we plan on? Sounds good. We can plan on the person table. We are not asked for a qualification on the person table, so we can move on to the join. The only other table that we have is the encounter table, so we'll join to the encounter table. Now we need to link the encounter table to the person table. What is the common field between these two tables? Person ID will work for that linking statement. We have more qualifications here. One thing that we are asked for were encounters registered in the past year. We can use the reg date time field for that. One more qualification. We only want to see those encounters that have a medical service of emergency medicine. We can make this qualification against the med service code field. Now, if I can just remember what the code value is for emergency medicine. Actually, instead of hard coding that value, let's use a variable so that the appropriate value gets populated in the variable every time that our program is run. We can call that variable emvar and then define it in just a moment. There's some information that we're going to need to create this variable. The primary piece of information is the code set. Remember that we can find that by right-clicking on the field in the Fields tab of Query Builder and selecting Properties. Okay, code set 34. We can click the OK button and then the Close button to close out Query Builder. We will declare our variable above our select command. We can manually type this out, or we can use the Add Code Value wizard in the Tools menu. Code Set Wizard. Click the button next to the Code Set box to select our code set. Type in 34 in the code set number field and then click OK. We can now enter in part of emergency medicine in the filter field to help find the row that we are interested in. That will work. Now we need to select the appropriate column where the value is unique. I'll select the display key from the type dropdown. Ensure that the value is added to the expression field box, and then click the Add button and then OK. I'll change the variable name to match what we provided earlier. Let's clean up the selection list and build out some expressions. EID should work for the encounter ID field. Reg date should work for the reg date time field. For the med service code field, we need to think through this one some. Since we're using the union result set operator, this field could display different data depending on what query that is coming from. A more generic name, like code, may be more fitting than the expression name that Query Builder created for us. Speaking of the expression that Query Builder built out, Do you see anything that could cause a problem when trying to match the data type with the field that would be contained in the result set operator? If you're eyeing the UAR get code display, then you're looking at the right place. That technically would work in the parent query. However, that UAR cannot be used in the select contained in the result set operator. If we had it on one, but not on the other, then our data types would not match up. The one with the UAR would return a C40, and the one without would return an F8. This UAR needs to go away so that our other query will be able to match the data type. Don't worry, we can add the UAR get code display back in using the report writer sections. Name will work for the name full formatted field. We were asked for one more thing to be included in our select list. That is an expression telling us which query the data is coming from. We can use side equal to EM for emergency medicine. That takes care of our parent query. Let's start the union query. We'll move past our last qualification, but before the with clause. We have a couple of options here. We can manually type out our entire union query, or we can manually add the union and some base select command syntax, and then use Query Builder to finish out the query. Let's do option 2. Let's also add in the RDB union control option to ensure that all our fields are passed down to the RDBMS. Inside the union operator, I'll add a simple select from the person table, as we'll need some data from there. For this query, we need to make the same date range qualification as the other one. So we'll need the encounter table again. Now we need a table that will allow us to see a relationship with a social worker. Any thoughts? If you're thinking of the encounter personnel relation table, then you'd be correct. Good job. Now to the fields. Remember, we need to match the order and data types of the fields in our parent query. There are several ways that we can build out our expressions so the names match those that we created in our parent query. One option is to just select the fields that we need and make changes later, just like we did with the expressions in our parent query. Another option is that we can build them out as we go in Query Builder using the Add Expression button. We can do that so you can see another method. You'll click the Add Expression button, drop down the table list and select the Encounter table. Then check the box to display all fields per table. We can start building out our EID expression. Then bring over the Encounter ID field. That expression is done. Now we can click OK. We'll follow the same process to add the rest of the fields. For our code expression, we'll use the Encounter Personnel RCode field from the Encounter Personnel Relation table. For our side expression, we'll use SW to indicate the social worker side. Now for our qualifications. Since the select is contained in the union result set operator, we cannot use the plan and join syntax, and we'll have to use the single where clause. We can start with our linking statements. Let's link our person table to our encounter table. We can do that using the person ID field. Then we can link the encounter table to the encounter personnel relation table. The common field between those tables is the encounter ID field. Now we need our date range qualification to qualify encounters registered in the last year. All right, we have just one more qualification to make that will qualify on only those personnel relationships to social workers. We can use the encounter personnel R code field to make that qualification. For the value we'll check against, we can build out a variable that will be populated with the appropriate code value when our program runs. Let's call that SWVAR. To build out that variable, you'll need to know what code set holds the code value for the encounter personnel R code. We can check that in this tab by selecting the encounter personnel relation table in the table dropdown. Then click on the All Fields radio button. Then scroll down to the field that we need more information on. Right-click and select Properties. Excellent. Code set 333. OK, and then close. We can see our select that we just built out is contained in the union. We need to create our SWVAR variable. We can do that near the top of our program. Tools menu, Add Code Values. Then the Code Set Wizard button. Then the button next to the Code Set field. 333 for the code set number. And then click OK. We can filter by typing in part of social worker. Notice there is social worker twice in the meaning column. We cannot use this column because the value is not unique. Thus, the UAR get code by would not know which one we want and would return a negative number. This value is unique in the display key column, and I can more easily see which line that I'm truly interested in. Change the type dropdown to display key and select the first row. Then the Add button and OK. Let's change the variable name to match what we used below. We need to select into our output device, so into $outdev. It would be helpful to sort the data. We can add an order by clause after the closing paren for the union. Let's sort first by the name. Name is the fourth item, so 4. Then, by the reg date, which is 2, let's make sure that we have results returned before adding in our report writer sections. Save, compile, confirm that there are no compile errors, then run. Looks good. We can see that the data is sorted by name and then by reg date. The code column isn't particularly easy to read since we are seeing the code values rather than the display values. We can clean that up using the report writer sections. Remember that we can use the report writer sections for display or additional processing. We'll use it for display here. Let's use the head name sort item section to process each name just one time. Side note, ideally we would use the person ID as it is a unique identifier to ensure that multiple people with the same name pool formatted do not get combined together. Our result set is simple and only tests data, so we'll stick with what we have. We can write out the name in column 0 and then advance to the next row. To keep our recommendation of matching our head and foot sections, let's add a foot name section as well. We can add a row +1 to place a blank line between people in our output. We can add some more information to the output, like showing the fields from our select list. We can do that in the details section to allow us to see all the data. We can now add those fields. We want to see the display value of the code fields rather than the code value. We can build that out here. Then display that value. And then the rest. Save, compile, confirm that there are no compile errors, then run. Looks good. We can see that DVDev has a relationship to a social worker and an emergency medicine encounter. We can see that Alvin and Amber have an emergency medicine encounter with no relationship to a social worker. Andy only has a relationship to a social worker. The hospital could then take this information and start doing some trend analysis on it. Let me give you a visual of what the RDB Union control option is doing for us. Let me comment it out. After the end go, I have the set trace RDB debug so we can see what is passed to the RDBMS level. I also put the object name followed by the output device parameter. The null device will work for this test, and then go. Save. When I click the Include Compile button, it will compile the source code and then run the commands after the end go. Okay, we can see an error from running the program. It's an Oracle error. Query block has incorrect number of result columns. That sounds like what we were trying to avoid. Let's look at the listing file for a clear picture of what is happening here. Scroll down to the bottom so we can see the queries passed down to the RDBMS. I've cleaned up the output to make it a little easier to read. There are a couple of differences between the queries. The first difference is that the parent query is missing the side expression. That fails to honor our requirement that we have the same number of fields be sent down for both queries. The second difference is that the fields are in a different order. Notice that the parent query lists the name full formatted field first, but the union query has it fourth. This then offsets the remaining fields in the parent query so that they do not line up properly with the union query. This also fails to honor a requirement that the fields must be in the same order. If we had the RDB union control option, then we would have passed down all of the fields and our requirements would have been met.